for inverse secant, I always need to be referring to the regular secant graph. And frankly, I always need to create the regular secant graph by first looking at the graph of cosine and knowing where I'm going to have an asymptote. So I have a few ordered pairs. I have 0, 1. I know this point is going to be pi negative 1. But if I look at the graph of secant, let's also write some limit statements about the asymptotes. I know the limit as x approaches, this is at x is pi over 2. Pi over 2 from the left of secant of x is infinity, and I know the limit as x approaches pi over 2 from the right of secant x is negative infinity. Those are vertical asymptotes, so I know I'm going to have horizontal asymptotes. So if I'm looking for a limit for inverse secant, in this case, x is going to be approaching infinity. The function is going to be approaching pi over 2 from the left. For this second one, for inverse secant, x is going to be approaching negative infinity, and the function is going to be approaching pi over 2. So I'm going to have an asymptote at y is equal to pi over 2. Oh, and my domain here is, well, the range for this had been negative infinity up to negative 1, and then 1 to infinity. So that's going to be my domain here. The range for this function became the domain for this function becomes the range for this. So the domain for this is 0 to pi over 2 and pi over 2 to pi. Okay. So let's get some ordered pairs. 0, 1 is going to become 1, 0. And pi negative 1 is going to become negative 1 pi, which is going to be up here. And then I'm just going to use my asymptotes. As x approaches infinity, the graph has got to get very close to pi over 2, and it's always going to be a little bit beneath it. As x approaches negative infinity, whoops, we're going to get very close to pi over 2 and be a little bit above it. And for secant, the range, again, is 0 to pi over 2, pi over 2 to pi. So the angle whose secant is 1, I need to think about this as if the secant is 1, then the cosine is also 1. So the angle whose secant is 1 is 0. The angle whose secant is negative 1, well, I'm looking over here at this ordered pair, which is negative 1 pi. So that's going to be pi. The angle whose secant is 2 over root 3, well, I know the cosine would be root 3 over 2, so I'm dealing with pi over 6. So this is pi over 6, but if we have a negative 2 over root 3, we must be in this quadrant, so that's 5 pi over 6. And if I'm looking for the angle whose secant is 2, this is the same as the angle whose cosine is 1/2. If the cosine is 1/2, I know we're at pi over 3. But where the cosine is negative 1/2 is going to be 2 pi over 3. And the limit as x approaches infinity of inverse secant is pi over 2. As x approaches negative infinity, that's also going to give us pi over 2. And this is neither even nor odd. So that's nothing.